This animation shows a typical application of a pressure-balanced expansion joint for combined axial movement and lateral deflection. Both the anchor at the end of the piping run and the turbine are intermediate anchors, and only directional guiding is required. If the expansion joint is located close to the turbine, guiding between the turbine and the expansion joint may not be required. The only force imposed on the turbine is that which is required to deflect the expansion joint. This animation shows another turbine application, but in this case, the anchor point of the turbine is located some distance from the expansion joint, and the expansion of the turbine between its anchor and the expansion joint is absorbed as lateral. An intermediate anchor is used at the center fitting of the expansion joint. If the expansion joint is located close to the turbine, guiding between the turbine and the expansion joint may not be required. This animation shows that a pressure-balanced expansion joint can be used at changes in direction other than 90 degrees. In this case, the growth of the longer piping run is absorbed as axial movement of the expansion joint, while the thermal expansion of the offset piping run introduces both axial and lateral components or deflection of the expansion joint. Only intermediate anchors are required at the ends of the lines, and directional guiding is used. The guide on the offset run may be used to absorb the axial movement forces of the expansion joint if the piping is not sufficiently stiff to transmit this directly to the intermediate anchor. This animation shows a common application for which a pressure-balanced expansion joint is well suited. Under various process conditions, the vessel and the vertical pipe may expand at different rates. By installing a pressure-balanced expansion joint as shown, the differential vertical movement is absorbed as axial movement of the expansion joint, and the thermal expansion from the center line of the process vessel to the piping is absorbed as lateral deflection. The piping may then be secured by an intermediate anchor at the bottom and furnished with a directional guide adjacent to the expansion joint. In many cases, external structure is not available at the upper elevation of the process vessel, and the guide must be connected to the vessel itself. Using this arrangement may result in some bending load upon the piping, especially where the vessel is tall and subject to wind loading, deflection, or similar effects. Where the guide is attached to a rigid external structure, the expansion joint must be designed to absorb wind loading, deflection, and other similar loading as lateral deflection. Where large amounts of lateral deflection are involved, a pressure-balanced universal expansion joint must be used. In this design, two bellows are used in the flow end of the expansion joint and a single bellows in the balancing end. Normally, as shown in this animation, the balancing bellows will be subjected only to axial movement of the tie rods that are properly designed to rotate or pivot at their attachment points. In order for a pressure-balanced expansion joint to function properly, the pressure thrust restrained by the tie rods must exceed the axial movement forces of the expansion joint. In a large diameter, low pressure application, it may be impossible to utilize the pressure-balanced expansion joint to eliminate the pressure loading, or at best, the effect may be uncertain. In such cases, some other expansion joint design must be considered. Pressure-balanced expansion joints are not recommended for use in services where the pressure equalizing connection between the flow bellows and the balancing bellows may become plugged or blocked by the flowing medium or by contaminants. Where flow considerations permit, this problem may be overcome by the use of a T as a center fitting of the expansion joint rather than an elbow. In some cases, the pressure for the balancing end of the expansion joint has been introduced from a separate pressure source, but this is considered somewhat hazardous. A control failure, or even a slow control response, may result in a partial or full pressure loading being imposed upon the piping or equipment, thus overcoming the initial reason for using the pressure-balanced expansion joint. A control failure, or even a slow control response, may result in a partial or full pressure loading being imposed upon the piping or equipment, thus overcoming the initial reason for using the pressure-balanced expansion joint.